Welcome everyone to the last of these essentials of math modeling workshops. So if you don't remember, my name is Wesley, and so the focus of today is going to be kind of writing the report and just going over a few, maybe some tips and tricks, but in general, things that you really should not forget to include when you're preparing your submission. Okay, and so certainly, one of the key aspects of doing math, especially math modeling, is sharing your results and describing your results in ways that others can easily understand, figure out what you're talking about, and then interpret for whatever they need the results for. And so so that'll be the focus of today. And of course, once you start writing, you'll have a draft, then you revise, find typos, correct things, etc. But hopefully one of the other things that you get away from the session is as you're working on these problems and developing your models, etc., take a lot of notes throughout the process, and in a sense, let your report kind of grow organically, right? So that you don't spend all this time, coming up with results, generating figures, whatever, and then for the last, few hours, you say, okay, we know what we're talking about. Let's actually write everything down now. Instead, maybe kind of the biggest piece of advice that I'll share is, take a lot of notes as you're putting together your model, as you're trying things out, as you decide, oh, maybe this assumption didn't work, etc. Right? Because in that way, you let your notes grow organically, and then it's a lot easier to convert those into like a final report. Okay. Cool. So some reminders, the last set of reminders. Thank you all for your continued participation and showing up and being active members of these workshops. These workshops are being recorded and uploaded to YouTube. One of the other reminders that was here for past few weeks was don't forget to register, put together a team, etc. I believe registration closed maybe about an hour ago. I don't know, sometime today. So hopefully everyone here is set, good to go, ready to participate. And yeah. So the plan for today is, so in this first hour, I'll talk about aspects of writing, right? Things to remember, other tips and tricks, etc. And then in the second hour, Keshav and Owen will, you might say, it might be a little bit of a Q&A, but also just, giving some advice about, what it's like to compete and some more things to keep in mind as you actually take part. And Owen and Keshav both competed in previous M3C challenges. So, they're excellent sources of wisdom and advice. So, yeah, cool. And so then, of course, the other volunteers we have here are Nathan, Julie, and Chao. So if you have any questions, don't hesitate to ask in the Q&A. One of us will provide an answer. Okay. Cool. So what are we going to be doing today? So the plan for today is the following. So we're going to mention a few of the important pieces to include in a report. And in particular, you should include these because triage judges and judges are looking for these pieces, and they really help frame, how you set your model up. Are you discussing everything that you really should be, etc. So we'll recall, right, the important pieces to include, after which we'll mention some general writing tips. After that, we'll do a little case study of the one of the 2022 practice problems for M3C, and I'll talk a little about kind of how I approached it and how I started writing notes and putting together some sort of report. And then afterwards, I'm going to introduce, if you haven't already seen it, this kind of website and typesetting software called Overleaf, so Overleaf is the website, LaTeX is the typesetting software. And so especially if, you're doing a lot of math, typing up a lot of equations, things like that, LaTeX is a very, very wonderful, I don't want to call it like a word editor, but it's a typesetting software that you really should consider, looking into. In particular, because, so for example, Google Docs, they support a lot of the commands that are used in Overleaf and typing up math quickly. And so then, right, if you're using a word editor to put together your report, it'll make typing things up so much quicker. Yeah, so that's the plan for today. Of course, if you have any questions, don't hesitate to ask, either in chat or the Q&A. And yeah, so let's get started. Okay, so right, when you're writing the report, oftentimes, well, pretty much every time, M3C will ask for a few specific pieces to include, including something like a one-page summary of what your team did. Oftentimes they'll also ask for, or COMAT might do this, but there might be like a more informal letter. But otherwise, right, the important pieces to include are kind of a formal introduction to how you're approaching this problem. You'll want to have some more concise problem statements or kind of actual problem statements where you're getting at, how you're quantifying the problem that you were given. And then of course, the body of your solution where you actually, write things up and, have the actual content. And then you'll want a nice sort of conclusion piece to wrap everything together. Okay? And in particular for M3C, right, even though the problem is kind of split up into three parts that build on each other, judges are looking for connections between all three parts. And so kind of that reemphasizes the importance of, this formal introduction and the conclusion that can effectively tie your solutions to all three parts together into one cohesive, model and report. Okay, so these are the kind of important pieces overall for your entire document. And then some other pieces to really keep in mind are, you might say, things that kind of you want to specifically address. And these include model assumptions, right? And more than just, stating the assumptions, is it easy for whoever's reading it to find what your assumptions are? Okay, so be sure to state the assumptions that you're making and make it easy to find. What's often missing from reports is some sort of sensitivity analysis, right? As you build these models, there are a lot of parameters that you choose, right? How do your model results change depending on these parameters? Okay, always looking for some sort of mention of that sensitivity analysis. Otherwise, be explicit about what your model is really good at and what it's not so good at. Even if you think, stating weaknesses of your model, even if you think that might kind of detract from, I don't know, building up your model, it's important to explicitly state these things so that, as a judge, we know that you're aware of kind of the scope of your model, right? And really saying, these are the things that this model is good at. This is where this model is applicable. So if you wanted to try it for this different thing, maybe it's not so applicable there, okay? Being explicit and upfront about these strengths and weaknesses will really make your report stand out. Of course, any appendices with code, or if you want to include like a table with data, these often go in appendices, especially if you're competing and you want to submit your report for consideration for a technical computing award, right? Having a nicely formatted code with comments, everything really goes a long way, okay? And so then, of course, anything else that's explicitly asked for in your kind of in the problem statement, be sure to include. Okay, and this can mean either specific sections or aspects to talk about. Otherwise, just make sure that you're actually answering what is asked of the problem. Okay. Yeah. So all of these things are kind of general pieces of any report, but when you're putting together a report, do make sure that you include each of these things. They're easy to find, it's well formatted, because that'll certainly go a long way, for the judges that read it. Okay. Okay, and so then, sure, right? It's a math modeling competition. You're doing math. You're putting together models, looking at data, doing results, right? But of course, when you go to present your results, it's a matter of actually writing things effectively, writing things well, and making it easier for your reader to follow along. And so, of course, one big piece of advice is spell check, right? Even if you think your word editor or your typesetting software can catch all of the errors, sometimes you might miss them. Sometimes, right, you have the wrong word, but it exists as a word, so like it's not going to flag it. So actually read through your report, double check everything, make sure that there aren't any of these, you might say, like simpler mistakes. Label your figures and tables, especially because it makes it easier to then find them, right? If you say, for example, see the figure below, kind of in the text, and then the person goes to look below, but the word editor or whatever, it auto-formatted, and so it moved the figure like far away while you're looking below and you don't see the figure. Okay, so definitely include kind of labels for your figures so that you can explicitly say, right, see figure whatever. Same thing goes with tables, right? Make it easy to find other pieces in your report. Do include references. Generally, it's not super important to be super precise about, APA or Chicago or whatever other style of reference. But as long as you are referencing things and you can say, here's a fact that I'm using, here is the website or the paper or whatever else I got it from, right, do include references, okay? Some other aspects, right, significant figures can make it a lot easier or a lot harder to read your results in your report. So, pay mind to significant figures. Scientific notation, do that. The other kind of the main point though is, right, don't leave writing to the last minute, okay? As you're working on your model, as you say, well, here's an idea, what assumptions do we need to make this idea work? Write those assumptions down, okay? Because this way, what you're doing is you're adding to this, collection of notes that then you have everything written down. And so when it comes time to actually go through and, refine things and, polish it and turn it into an actual submission, you're going to have a much easier time than if, you waited to write everything out linearly at the very last minute. Okay. Cool. And so then in general though, right, right, this is very much just the surface about tips and tricks for writing. There are plenty of other resources out there that can give you a lot of ideas for how to approach writing. And so one from Keshav and I, where we used to go to school, University of North Carolina at Chapel Hill, they have a writing center and I can open this in a new tab. They have a writing center that has a lot of little worksheets on a bunch of different, topics, approaches to brainstorming, quotations and using them effectively, etc. Okay, so this is one very, very excellent resource if you're not sure about, what you're writing, or even how to go about organizing and coming up with ideas, etc. Okay, so this is one excellent resource. The University of Utah also has a writing center that has tips. So, look around, use a lot of resources, try a bunch of different things, get creative. But in the end, make sure that, whatever you put together, whatever you write is clear, can be followed, and, says what you want it to say effectively. Okay. Cool. Okay. So let's see. Okay, so before we do this case study, so are there any questions on kind of general writing tips, tricks, etc. before we move on? Okay, cool. Okay, so kind of the next bit is going to be this case study on, what it looks like to more actively put together notes and kind of start constructing this document in real time. And so it won't actually be real time, but I'll indicate kind of going back and forth how everything kind of came together. Okay. So the M3C has available a number of practice problems. And so one of them, if you follow this link, and I guess the slides will be shared here in a second, but if you follow the link, it goes to this, this page on the M3C website called Modeling Disease Spread, Containment, and Prevention. Okay. And so this practice problem had a live chat session earlier today. And so if you're curious, you can read through this, and then if you scroll down, you can see all the questions that were asked. But what we're going to do now is we're going to read through the start of this and then take a look at question 1 and sort of see how we can, start building a model and then start adding to a report at the same time. Okay. Okay, so what is this question? Since the beginning of the COVID-19 pandemic, the world watched as various precautions and treatments were proposed, developed, and rolled out. We were able to see how various countries fared based on the measures they implemented. Professionals who track diseases and offer advice often use variations of a type of mathematical model called an SIR model. In this type of model, we assume that at any given time, people in a population fall into one of 3 categories: susceptible, infected, or recovered. The number of people in each category changes over time depending on the interactions among the people and the properties of the disease. This type of model focuses on the rates at which people transition from one category to the next. This website, which you can click and follow, this website gives some basic information about the SIR model and provides an example of how you might get numerical and graphical results using Excel. Okay. So if we look at the website, the key thing is you have 3 boxes. People are susceptible, they can get infected, and then they can recover. And there are some equations that tell you how people move between these boxes. Okay. Okay. Suppose we have a new novel disease. Let's call it ND22. There are things we can do to prevent the spread of the disease. Preventative measures such as wearing masks, PPE, cleaning practices and products, social distancing, vaccine. And there are things we can do in response when someone has contracted the disease. Response measures such as quarantine, prescription antiviral drugs that minimize the duration and or severity of illness, medical treatments like hospitalization, use of ventilator. While response measures are typically provided to any infected patient in need, if they are available, leaders may be tasked with creating policies to determine how preventative measures are distributed. Ultimately, that is what you will be asked to do for ND22 by modifying the standard SIR model. As you model, you should make assumptions about how easily the disease spreads and how long a person remains infectious. You may want to find examples of model parameters for other diseases, such as the flu, COVID-19, chickenpox, so your model has some realistic parameter values. Okay, and so now we get to the questions. And so for this part, I'll only focus on question 1, okay? Maybe it took me about an hour and a half to 2 hours to work through it, get back up to speed on MATLAB and write things out. But you know, during an actual kind of challenge, right, keep in mind that, right, you're not just answering question 1, you also have to take a look at 2 and 3. Okay. Okay, so question 1. One way we can improve on the basic SIR model is by considering that the spread of the disease and the severity of outcomes are different for people of different ages. We can account for this in the SIR model by dividing the total population into subgroups based on age. That is, create a model that has multiple S compartments, 1 for each age group, multiple I compartments, 1 for each age group, and multiple R compartments, 1 for each age group. Since it is possible for a young person to spread the disease to an older person and vice versa, you will need to consider interactions among various groups. Do not yet consider any preventative treatment or response measures. Apply your model to a specific country, one for which you can find population demographics, to demonstrate the spread of ND22. Okay. Right, so to recap, so the key aspect of what we're being asked is essentially implement an SIR model, but instead of just a susceptible, infected, and recovered population, now we may have multiple susceptible, infected, and recovered populations based on age. Okay. Okay, so are there any questions on kind of the problem setup or what we're being asked to do? Similarly, does anyone have any ideas about how we might start setting this up? What things we might want to, I don't know, write down, examples we might want to look at? What are some initial thoughts for this problem before I kind of start talking about how I approached it? Maybe what age groups might you want? Okay, so you have one response. So first write down the basic SIR equations and then modify them based on other variables concerning interactions. Okay. Another response, I would start by brainstorming some of the factors involved. Okay. Right, so one question is, right, so we're told, right, create a model that has multiple S compartments, 1 for each age group. What age groups might you all want to, you know, start with, or what might be reasonable? Yeah, what are your thoughts about, you know, what the age groups might be? Okay, so one response. You can I'm guessing you can group school children into one category because transmission rates will be similar in schools. Another response, child, adult, senior. Another response, COVID-19 vaccine was authorized for use for specific age groups at different times. Perhaps a good set of age groups could be based on those groups, okay? All great options. Yeah, okay, so what we'll do is then I'll start to go through kind of my thought process and some of the scratch code that I put together, and then indicate how kind of my notes started coming together, okay? So what I did is I opened a new MATLAB live script, and of course all of this you can do online, and this live script will be available after the session. And so what I actually did is, so if we go back to the problem statement, down here they have an example of how you can implement a simple SEIR model in MATLAB, which isn't exactly an SIR, but it's a starting point. So what I did is open that live file, took a look around, and then, based on a lot of the code that was in here, kind of copied it over and started tinkering with it for how I wanted to approach it. Okay? And so we see, so another response about the age groups. So age groups we can use toddlers 1 to 4, children, teens, young adult, adult, seniors. And so in total, that's what, 1, 2, 3, 4, 5, 6 groups. Okay? And so I can say when I started thinking about this, I was thinking of using 5 age groups. Okay, so you might say kind of toddlers and children together, in part because transmission rates in schools, or I don't know, kids might not be super careful with where they sneeze or if they rub their nose and then wipe their hands on anything. So transmission rates for younger ones are going to be different than, say, for teenagers, than for young adults, than for adults and seniors. So originally I was thinking 5 groups, roughly like that. And then I actually started coding things, and I decided that it was going to be a lot easier to not have 5 groups interacting, but instead simplify it to 3. Okay. Okay, and so then what that looks like is, I said, right, so here, where is it? Here is the SEIR code block from this MATLAB live script. Okay, so what I did is I copied this and I said, okay, what does it look like to modify this instead of just one S, one I, and one R? If instead I had, right, say multiple S's, multiple I's, multiple R's, the observation was, well, you can modify things in a not bad way, just keep in mind that maybe, the susceptible numbers are the first few entries of kind of this vector, infected, or the next few, recovered with the next few, etc. Okay. And then if you kind of write everything out, and especially if you're comfortable with, matrix multiplication and some of that stuff, the formulas are not bad at all to write out. And so I won't get into details with this, but everyone is welcome to and encouraged to, write these things out and double check that, this is a version of the SIR model. But what I realized is, well, for multiple interacting groups, we need to specify the rates that these groups are interacting with each other. And then I decided to, keep everything in terms of a matrix, so it's a little easier to write down. But if you write everything out, right, and kind of you're hard coding all this stuff, right, with 5 or 6 groups, it's going to be a lot. Okay? And so I decided, well, for my initial sort of analysis, I'm going to start with 3 groups. I'm going to find some assumptions or find some references that can kind of justify that, hopefully, and then kind of see how it goes from there. Okay? And so that was one of the first things that I started writing down. And so I started writing down assumptions. I said, well, what is the assumption we're going to make for this compartment model? the dynamics of how this disease spreads is going to be similar for these 3 age groups. Okay. And so, of course, right, one question is, well, why did you choose these age groups? And so I said, well, part of the reason is because I can find data for these age groups. Okay. And so there's this census brief for the US population. And if you scroll down, you can see population by sex and selected age groups, 2000 and 2010. And so I said, oh, okay, well, for 2010, here's this proportion of population under 18. Here's this proportion between 18 and 44. And then this proportion here is going to be above 45. And so again, I wanted to keep it at 3, so I lumped 65 and over with 45. Whether that's a good assumption or not, that's up to you to, decide and modify. But I said, we're going to go with that. Okay. And because we wanted to modify an SIR model, or maybe justifying that it's an SIR model, we're going to say, well, all susceptible people are equally likely to get infected by all other infected people, right? So we're not accounting for spatial or geographic distribution, et cetera. Okay. So these were kind of going into saying, well, right, this one is saying, let's use an SIR model. This one is saying, we're only going to need 3 compartments for each S, I, and R. And I chose 3 compartments mainly because I could get the data and I'm lazy and didn't want to hard code a lot of stuff. Okay. Maybe later on, I realized that, oh, maybe this isn't actually super satisfactory. Maybe I should go back and modify it for 5. And then by that point, hopefully it's not too bad. Okay. But this is a start. Okay. So this assumption section was the very first thing that I started adding to. And I said, okay, well, let's actually put together the model. We've decided on 3 compartments. So that means we're going to need 3 kind of S variables, right? S1, S2, S3. We're going to need 3 I variables, I1, I2, I3, and then 3 recovered variables, R1, R2, R3. And so what I did then is I jumped down here and I said, okay, what does this model actually look like? So I said, well, sure, standard SIR looks like this. Okay, great. What are these parameters? Well, beta and gamma are the infection rate, recovery rate, N is the total population. And this bit about R naught, this I didn't have yet. Right? And I'll say when accounting for this reproductive number, when this came into play. Okay? But I said, sure. So this was the SIR. How do we modify this for multiple interactions? And I said, well, what is a change in susceptible, the kind of ith susceptible population? Okay. So maybe for I equals 1, that'll be, right, how many susceptible people below 18 years of age get infected? And so he said, well, that's going to be, so that's going to depend on the proportion of susceptible people in that population, as well as the number of infected people in population J, right? Under 18-year-olds can get infected by other 18-year-olds, but under 18-year-olds can also get infected by adults, or they can also get infected by elderly people. And so I said, okay, well, let's account for all of those possibilities. And for each possible interaction, group 1 with group 1, group 1 with group 2, group 1 with group 3, let's just call those variables beta ij. Right, so beta ij is the infection rate on group I from the infected group J. Okay. So then this is going to be how many susceptible people in each of the groups gets infected. Okay, well then how is, right, what is a new number of infected people? Well, that's going to be however many susceptible people were infected minus however many infected people recovered. Okay? And so right here we say, well, right, if you recover, that doesn't really depend on right, any other infected group, right? You recover if you recover. It doesn't matter if you're interacting with, you know, younger or older person or whatever. And so while these parameters beta, right, they were coming in between, you know, between group interactions, these parameters gamma, which tell you, right, the recovery rate for each population, those just depend on the population, right? And then of course the recovery rate is just that piece, okay? And so we said, okay, well, here's how we decided to, you know, encode the different compartments. And so let's write out what these things are. Coefficients beta are the rate at which individuals from population J infect individuals population I, gamma is the recovery rate, and saying, right, intuitively, right, the rate at which infected recover only depends on, right, if you're infected, not any other group, okay? Right, maybe this could be an explicit assumption that you're making about the SIR model. Maybe it doesn't need to be, but I decided to write it explicitly here. Okay. And so here was the basic, right, quantification of how I was going to approach this. And so I said, okay, let's write down what all these variables are in a way that's easy to reference and easy to find. And so up here, table, variable, description, right? Not a whole lot added, but, or I guess I should say, the information here is also encoded in this paragraph down here. But the nice thing is, it's really easy and really quick to look all this stuff up, right? So if later on I have a more complicated model and I forget what R0 is, for example, I can quickly look it up, okay? And so one other note, this row of the table wasn't here when I first wrote down these other variables. I added this later. Okay. Okay. So that's all for now. So far, I've only added these two assumptions. I wrote out bits about the model development and I wrote down the variables. Okay. And so at this point I said, okay, well, here are the equations. Let's actually write them down, see how they behave. And so then that's where this comes in. So we said, okay, so scroll back up. So here I wrote things down, and this was very much just doodling, trying to figure out what viable parameters were, trying to get decent looking plots, figuring out what's worth drawing, right? So here in this plot, this is the susceptible population for kind of adults, infected population for adults, and recovered population for adults for parameter choices that very much I was, you know, playing around with, etc. And then here, this is just the infected population for each group, okay? And I chose some value of n in, yeah. Point I want to make is all of this, I was very much getting a sense of, well, kind of how to use MATLAB Live, but also, you know, how these different pieces come together and making sure that the code was working. Okay. And so I said, okay, great. Things are working fine. I'm comfortable with the code. I'm comfortable with how the pieces come together. So let me actually start, you know, putting together the model. And if we scroll back up to the question statement, apply your model to a specific country. And the other important piece I want to highlight is find examples of model parameters for other diseases. So when I was playing around with all of this stuff, I was like, well, sure, you move, you know, the interaction. This is kids that infect other kids. And so it might change the infected population a bit, but, you know, anyways. So it was like, okay, let me actually try to match this to data. And so I said, okay, why not just focus on the USA? Okay, USA has a population of a bit over 300 million. So N we set to 300 million. Okay, then I said, okay, well, if our compartments are the population in each group, right? So under 18, adults, and then older than adults. said, okay, well, what are those proportions of the population? And so then that is where this bit explicitly came into play. I could say, oh, well, under 18-year-olds in 2010, it's about 74 million. So let me use that number. 18 to 44 was about 113 million. So let me use that number, et cetera. Okay. So I started bringing this stuff in. And then I said, okay, well, what about, matching this to another disease? Maybe that'll give me a better sense of what these parameters would look like. Okay. And so I said, okay, well, what's a good disease to get numbers for and see how stuff, behaves? So I said, well, let's work with COVID. Let's get COVID data and then try to match ND22 to that. And so at the least, we would have some numbers there. And so that's what I said. I said, well, let's make an assumption. ND22 behaves similarly to COVID. And the SIR model parameters don't care about the geographic region. Okay. So this might be a bolder assumption. You might say, well, it's more different governments, different, public health policies are going to affect it. But I added this because when I was looking for data, I found an interesting paper, estimation of SIR models parameters of COVID-19 in Algeria. And so I said, well, it would be great to use this data. It's in Algeria and I'm using the United States as a model. So let me just pretend that results in Algeria work for the United States. And so then that's when I added this assumption in. Okay? I mean, kind of these two assumptions came in simultaneously, but anyways. And so, I just Googled SIR model COVID-19. This was one of the first things that popped up. And then they said, well, already one of the results is that their reproduction number, they estimate it to be this. And then I said, oh, great, maybe that's a more interpretable number, or maybe a better thing to put all this in terms of. Okay. If you scroll down though, they say, here's the SIR model, great. And then they get to some of these results and they say, well, here they're estimated gamma, which is a recovery rate, and beta, which is the infection rate. And if you look around, you can see that R naught, this number is estimated as beta over gamma. Okay. So if we know two of these values, then we know the third. And so I said, oh, well, R naught, what is that? That is, right, the average number of people that get infected from one sick person. So maybe I should just keep gamma as a recovery rate and then vary R naught. So then I can say, oh, well, what if every sick person infects two others? I can figure out what beta is and then plug that into my model. And so when I found this paper, I said, well, let me reframe things in terms of R naught. So let me add R naught to the model. And so then that's when I said, okay, how do beta and gamma relate? They relate to R naught by this formula. And I said, well, R naught is a new parameter that I'm going to use. So let me add it to this list of variables. Okay. And so then that's when I went back to my code and I said, okay, well, let's take a look at things. So we have the total population. We have the population in each group, total population in each group. We have initial conditions for our SIR model. All great. And I said, okay, well, let me put together these plots in a way so that I can vary this R naught. So here I can interpret this as, right, every sick person infects 3 other people. And then I'm going to use gamma from COVID model, and then I can compute beta. Okay. And then from all of this information, I can construct, this kind of matrix that I'm using for these interactions between groups. And here I just chose, kids, adults, and older than adults will, all infect each other by this basic gamma. Kids might be more infectious to adults, slightly less infectious to older than adults. But I'm also making an assumption here that, well, the rate at which a kid infects an adult is the same rate at which an adult infects a kid. And so I chose this just so it was easier to write everything down and pick numbers. But then I realized, oh, well, right, maybe that's not always the case. Maybe infection isn't, a two-way road, okay? Maybe adults are going to be more careful and won't infect kids as much. And so I said, oh, that's something that's important to write down. And maybe I didn't write it down explicitly. So I'll write it down here. Infection rates are symmetric between groups. Okay. So I said, great, here's an R naught I can vary. And so if we vary that here, right, these plots change, etc. And I was like, great, good to go. I can start getting results. I can generate plots that look like this. I said, okay, well, let me start writing these in. And so at this point, said, okay, so all of this was added. This point, I started writing down the results, okay? So I copied over some images and I said, well, the susceptible population curve might be worthwhile to use. So this label is wrong, so that's a note I need to make to change the label, but this looked like a good result to include. So I said, well, let's also include the infected population. Okay. So I added in these two figures. I said, well, I need to add figure labels. So I'm going to get back to that. And wherever I reference them, I'm just going to make a note that I know to include that later. And I essentially wrote down everything we just talked to, right? Focused on how this disease might spread in the US. Here's what we set N to be for the population. Here are the different groups by this reference, which I need to copy over from here. These are the proportions. These are what we're setting these parameter values to. And for each group, here are the curves. And so great, what are we looking at? Well, maybe one conclusion we can make is that, for these choices, and I think here I set R naught equal to 2, I said, okay, well, for these choices, let's measure time to peak infection population. And that takes about a little over 150 days. And that's going to be my initial result. Okay. And so, right, already at this point, I have about, what is this? 3 pages, 4 pages, a few pages already that when I go back to refine and say, okay, well, I need to fix the labels, fix the axes maybe, and the references, right? Kind of, it's most of the work is already done, right? Now it's just actually polishing and not actually, right, producing and writing everything, okay? And so I said, okay, well, let's include some sort of sensitivity analysis. And so I said, well, how do we measure that? Well, here's one idea. This is very much a draft. If you want any serious sensitivity analysis, make it a lot more quantitatively precise. And I said, okay, well, right, let's see how sensitive this is to say R naught. What happens if we change R naught? So I said, okay, for R naught 1, we get this infected population curve. For R naught equal to 3, we get this infected population curve. I said, well, for initial sensitivity analysis, let's, say something about what's happening. And so again, I decided, let's measure sensitivity based on time to peak infection. So for a lower R naught, it takes longer to get to peak infection. For a higher R naught, it takes a lot less time to get to peak infection. And so that's what I started saying here. And I was like, well, but maybe there should, right? You think if a disease is more infectious, I don't know, something along those lines, we should also be able to read out. And so then you say, okay, well, what about the axes? So for a smaller R naught, the maximum is at about 2 × 10⁶. For a larger R naught, maximum is about 5 × 10⁷, which is almost 10 times as much, okay, right? Which matches, it's more infectious, more people will get infected. Great. So I said, okay, well, let me write that down initially so I have something there. And then sure, we can go back and refine. Okay. And so all of this was very much a start for problem one, right? We said, hey, here's the SIR model. We adapted it. We matched it for some demographic data. Okay. We got a result. Is it a good result? I don't know. We'll return to it and refine it. But it's all very much a start, and it's giving us a lot of ideas for how we might proceed further. Okay. And of course I said, well, okay, right, what are the other important things to include? Strengths and weaknesses. Strengths, only thing I could think of right away was that, you know, it's a simple model and it works, right? But maybe it's not a super great setup, right? Because it's assuming everyone can infect everyone else equally likely. So I said, well, maybe that's not actually how it works, especially for a country that's as large as the United States. Another thing, and so this was what I was getting at with, you know, the symmetric, you know, kids will infect adults at the same rate that adults infect kids. I said, well, I used that assumption because it made coding the stuff and choosing these values a lot easier. That's something that I'll say is a definite weakness, right? Maybe these infection rates aren't symmetric. Okay. And so at this point, you know, I had all the basic pieces for part one. And so if I wanted to turn this into a more competitive solution, right, then I'd have to go back through, refine things, maybe alter the model. At this point, I might say, well, let's take 6 age groups, right? Like toddlers, children, teens, young adult, and then seniors. And then maybe that'll be more accurate. And then I could add that as a strength. There are a lot of issues with my charts right now, or figures, right? Titles aren't correct, so I need to change that. References aren't there, so I need to change that, right? But these are notes that I'm planning on converting into a submission, right? This is not near a submission right now, but it's a start, and it's saving a lot of time down the line if I were to, you know, wait for the last minute and then try to write out all this stuff and try to piece it together one at a time, or kind of linearly. Okay. Okay, and so at this point, all of this stuff had been written, and I had not yet written the introduction. And so I said, okay, well, what do I actually do in this part? So I say, great, what do we do, right? For initial model, we modified the classic SIR model to allow for multiple compartments. We adapted it to COVID-19 data and used population data from the United States. And so, sure, that's what we did. What do we get out of it? Well, our initial result is that, right, without any sort of mitigation strategies, peak infection time occurs approximately 150 days after the onset of the disease. And, you know, I wanted to say something a little more about like maybe how severe it was. And so what I did is I went through and I said, okay, well, for the simulation I ran, right, what's the infected population for children, adults, and older than adults? And the result was this number, which, you know, count over a few zeros, and you get about 100 million. Okay. And so this was my very initial draft for part one. Okay. Kind of maybe the point that I really want to hammer is, right, this didn't come together linearly. I did not write the introduction, then assumptions and variables, etc. Right, there was a bit of jumping around, there was a bit of adding things later on. Okay, but it was very much, right, working with this organic set of notes to put together, you know, something that you can then go back and refine and turn into a competitive submission. Yeah, okay. So this will be available, the code will be available. One thing that I've included in the slides, and I'll talk about very, very briefly, but more so leave as examples for you to explore after. There's a typesetting software called LaTeX, or tech. Some people call it LaTeX. It's okay to be wrong sometimes, but LaTeX is a typesetting software, right, that a lot of mathematicians, statisticians, and people working in very like quantitative and kind of STEM type fields use. So it's kind of similar to like any other document editor. You might say it's closer to like TextPad or Notepad, those things. But the key thing is it behaves more like a programming language than like Microsoft Word does. Okay. And so installing and getting it ready to use on your computer can be a lot of work. Luckily, there's a website called Overleaf that takes a lot of that like hard work away from you. And so here you can see a few Overleaf documents. But if you click new project, I'll give it name because I have something else, right? You'll enter this sort of area, which doesn't at all look like, you know, a standard sort of text editor. You know, things you notice: title, author, date. There's a begin document and an end document. And then there's this thing called section, etc. Okay. So what I did is I went through and I copied those Google Doc notes into an Overleaf file that I'll make available. And so here you could see, you know, it's the same notes. It's just for some of these things, I don't know, it looks a little prettier maybe. But one of the key advantages, especially if you get comfortable, is it's a lot easier and a lot quicker to type a lot of math. Okay. So like all of this stuff, which may look alien to you, if you practice, you'll get quick with it. But trying to put all of this stuff in Microsoft Word or Google Docs, for example, can take quite a bit of time. Okay? If you're not super quick with shortcuts and formatting, etc. Okay. Yeah. So yeah. Some of the examples that are specifically included in the Overleaf project, you can look through this, explore the code on your own. But LaTeX has a bit of a learning curve. So if this is the first time you're seeing this stuff, our recommendation maybe not to use it for M3C, but more so maybe this is planting a seed so that you hear about this thing and you say, well, if you're serious about, you know, making pretty math documents, over the next year, practice, try typesetting some things, a lot of Googling. But LaTeX, if you practice a bit, it can help, I don't know, get quick with typesetting and formatting and all of that stuff. But
all right, hello everybody. I'm going to put myself and Owen front and center. There we are. Awesome. All right. So for the next hour, we're going to be keeping this section pretty much open. Owen and I have kind of some advice, tips and tricks on kind of walk through a little bit of our own experiences with past years in the competition. I did this problem, or I competed in this competition back in 2015, and I was actually in the second place team that year. And Owen has competed just last year, and so therefore has a lot more relevant advice, because the competition has certainly changed in a couple of key ways between when I started and when Owen started. So if you have any questions about competition in the format, anything like that, or if you have any questions about any of the material that we went through over the course of our 7 workshop sessions, please feel free to type your questions in the chat. We have everybody here in attendance, and so we'll certainly be able to answer your questions if you have more concrete kind of questions. But for now, Owen and I are just going to kind of talk a little bit about our experiences. But Owen, since your experiences are a lot more recent than mine, I thought that it'd be better if you went first.
Sure, yeah. I guess This year just depends a little bit on if your team is going to meet in person or not. But last year with everything being virtual, at least in my case, due to COVID, definitely just focus on communicating with your peers, because that's something that can be a little extra hard, especially if you're meeting over Zoom. So work on just really make sure you're reaching out and trying to understand what other people are working on, so that you can all have one cohesive message. And especially with it being in a shorter window, like 14 hours, to do the actual problem, make sure that you aren't duplicating work, because if everybody's doing their own thing and not on the same page, you can end up doing a lot of excess work that's going to end up hurting your overall result, because you only have a limited amount of time to work on this. So definitely make sure you're communicating. If you're virtual, especially go that extra mile to reach out to the people on your team and make sure you're communicating on what everybody should be doing. So that's one big thing I guess I took away from last year. Let's see. Should I go to the Q&A in the chat or just keep going with tips?
If you'd like to answer the question, oh, sorry. If you'd like to answer the question live, you can do that.
Sure. I guess that's a hard question without knowing the problem, because it's going to depend a lot on the problem, what sources or where you should look for different data and things. But Google Scholar is a good place to start if you're looking for scholarly sources. And a lot of times it can have to do with your search terms that you're using. So if you're using, especially with math, it can be pretty sensitive to what search terms you're using to actually get things. So really try and think through the searches you are doing to get good results, I guess, is one thing. But it's definitely hard to give like a specific answer, like go to X, Y, or Z site without obviously knowing the problem statement yet. But definitely just think about using good search terms and being really specific, so that you can get good data, because there's just a lot of data out there. And also to note, if you are looking for data, there's Google dataset search, where there is, you can search for data sets, and that could potentially be another avenue to look at.
I'd say another answer to that question is, so when I did this competition, we weren't given specific data sets to use kind of as launching points. But what we were given were a bunch of links to articles and some other information on kind of the question itself. And from there, they had citations that we used and we kind of dug through that way. One advice I will give now that we actually are given data sets to use in the competition is that oftentimes, as we've kind of alluded to in our problem solving sessions, is that the data sets are subsections of, let's say, CDC or National Park Service, NPS data sets, and they're really large documents that have a lot more data that you could use. So I would certainly recommend, if there's some similar information that you see in the data set, but you want to find something that's slightly different, to take advantage of the original source of the data set that was provided for the competition. That might be a really good place to go. And then again, they might also cite something else, and then you kind of go down the tree of past literature that way. Yeah. So Owen, the question from Michelle about collaboration tools might be a little bit more relevant since you had to do everything online.
Definitely, yes. Obviously, a lot of Zoom meetings. I know my school had like unlimited Zoom, or like premium Zoom, where you didn't have like a cap on the number of meeting minutes. So just having meetings like that, but you can also use like Google Meets, just so you have that kind of face-to-face interaction. Even if you guys are working separately, just still having that Zoom link open. So if you have a question or something, you can just quickly ask your teammates and get feedback. So I definitely say find a lot of time to actually work together like that, especially since it's a short problem window. And then also, I haven't used this in competition, but I use like Notion before, where you can kind of, it's like a Google Doc essentially with a little more structure. So you can kind of break things up and put like checkboxes next to things. But an even simpler way would just be Google Docs, and then have everybody's name and what they're working on, so that everybody knows what everybody else is doing. And you can even do that inside of like a template for your report. So you can have your report template and then have people put their names or stuff where they're like working. So if you're doing assumptions, you could have your name there, and then like the assumptions you're working on, but keep it pretty rough. So just kind of like notes as you're going on. That way, when you go to write the report, you already have notes in there as well, and everybody else can see what you're doing.
We have another really good question in the chat. What would you say is the best way to manage time? And would you say splitting up jobs is a good idea? So I think, in fact, one thing that you might consider doing with your team prior to the competition is assigning some kind of roles. So one role that I definitely recommend you might want is somebody who is kind of the, let's say, the timekeeper of the group. You have 14 hours, and that 14 hours is fairly hard limit. You should really make sure that the document itself is finished in, say, 13 hours and 30 minutes, so that you're spending the last half an hour submitting the document, because you never know if your internet goes bad on you, or the website crashes, or you're having trouble converting to a PDF, anything like that. You need a little bit of time for that. Anyways, it's really important to have somebody who actually is watching the clock and saying, hey, everybody, we've spent X number of hours on part 1. We really need to move on to part 2. I think that that's really important. You might get a little annoyed by the timekeeper, but it is certainly in everybody's best interest. A common some feedback that we get from past competition participants is that they accidentally spent far too much time on the assumptions and the research generating, as opposed to the actual mathematical modeling. And so somebody to say, hey, let's meet all 5 people as a group, spend, let's say, 30 minutes all together as a group talking about what the plan is for the next, say, hour and a half. Then people might break off and work on things for an hour and a half, come back together, iterate, rinse, repeat. So I think that certainly some kind of timekeeper is a good idea. Another piece of advice that is kind of similar to this question of splitting up jobs is play to your team's strengths, right? If somebody is, a really good, let's say, MATLAB programmer, and you have a more difficult MATLAB question involved in your report, then you should dedicate some, let that person kind of take the wheel on that. Whereas other people might be more involved with actually writing the report or coming up with the model ideas for the next couple parts, right? So kind of leverage the experiences of your teammates, which parts they enjoy doing more, and really use that to your advantage.
Yes, I'd also just say I'm building off Keisha mentioning things about like assumptions taking a lot of time. I know personally the best assumptions that my teams have made have often been when we're doing the modeling process and we realize there's a hole in our model or something. So I'd say don't get hung up on the assumptions, just jot a few things down initially and just know that you're going to find more assumptions that you need later on in the process. And those are probably going to be stronger because you're going to be able to justify those in the context of your model if you wait and see what assumptions you need once you start modeling. So definitely don't get hung up on the assumptions or the initial parts, and know that those are iterative and will be changing throughout the whole competition.
Yeah, and hopefully we're kind of answering this question that's currently in the Q&A as well. This team that the participant is asked or is talking about is mathematicians, algorithms people. 2 people are very good at MATLAB. So I think that people who are better at coding, let's say, are kind of designated as the people who are doing the work of creating the algorithms. The mathematical inclined people are the ones who are kind of working on developing the model, talking about what components need to go into them. Is it going to be a probabilistic model? Is it going to be a differential equation model? What is that going to look like, right? So those are the people who are kind of creating the structure. Your coders are the ones who are actually doing the work of getting the results. And then some combination of those people are also working on writing the whole time as well. So I'll say that I kind of already said this, but I think one really good way of working with your team is everybody comes together so that everybody is aware of what everybody's tasks are at the beginning of your working. You read through every single part of the problem, and obviously you will start with part 1. You'll read through part 1, come up with an initial plan. Perhaps it'll be a statistical model, perhaps it'll be some kind of SIR model, whatever. Everybody is on the same page with that. Assign groups and then let people work, especially in a more virtual environment. I think that might be a better way to go. Let's see. One one person's asked, can you speak a little bit about the importance of the summary? Do you write it absolutely last? I don't know if I would say absolutely last. However, I would say towards the, let's say, latter third of the competition, especially if you have somebody who is good at writing and kind of telling a story. The summary is a good time to kind of turn your work into a story to tell other people. And so you kind of need a little bit more ideas of what your model looks like. And really, one thing that's really nice in the summary is to talk about the strengths and weaknesses of your model. So you kind of have to have those fairly developed in order to talk about those. Those are really strong points in your executive summary.
I guess answering the Q&A question about how often you would recommend to meet, it's just going to depend a lot on your own personal preferences, I guess, and how your team, how individuals on your team like to work. But one suggestion would maybe just be have like an ongoing Zoom link that you have in your group chat. And then when you're working on it, just join the Zoom link and other people can join as they're working, because it is a 14-hour period. So people might have to, leave to go do something else. But definitely, if you can, just collaborate as much as possible, because I know sometimes you get stuck on something that seems really hard, like a problem, and then you talk to somebody else and they have a different perspective that kind of pulls you out of kind of the narrow lens that you get. So definitely try and collaborate as much as you can, but also know that some people have to go do something else during the problem window. So just be flexible, I guess.
Yeah, so I would also add that these meetings should probably be, kind of organized ahead of time before the competition itself. These are kind of some, let's say, organizational things that we think that it will probably speed up just the process in general, make sure the team is working a little bit more efficiently. Maybe a similar thing Owen kind of mentioned and is relevant, especially if you're a virtual team, is that personally, I think it might be a good idea to not have a single person work on a single task all by themselves. So for example, if you have, let's say you have one person who you're going to designate as the lead programmer, that person shouldn't be programming all by themselves the whole time. They should be meeting more periodically with people so that they can, talk about problems they're having, some information that they would like to know, things like that, so that they're not just kind of stuck in their own little rut. Especially that is kind of the pitfall of creating groups and designated tasks, is that you kind of get narrowed in on the one specific task you're working on, and you don't look to your neighbor to see what they're working on. And so it's up to you all and your individual preferences for how often you like to be on Zoom and how long you like to be on Zoom. But definitely have people rotate around, make sure everybody's giving their opinions on everything, even though they themselves are not the lead on programming or writing or researching or model development. We had another question in the chat on imperfect data and holes in the data, how to handle this. This is perhaps a very difficult question, because I think this is, in short, this would end up being an assumption in your model that you would probably like to justify. I believe we had an example of this. It was, I don't remember who was presenting, but it was the National Parks data set. Wesley, was that you? Yeah. Where Wesley was showing us mean sea level rise data, and there were huge chunks of data missing. And so this was a clear assumption that Wesley had made for the model, which is that we interpolate linearly between holes in the data. Does that work? Does that not work? Something that you'll have to assume and then justify. Again, you have to remember that you only have 14 hours, so you don't have the most amount of time to kind of explore all of your options. The best way to handle imperfect data is to make a decision and then make an assumption and make a justification. Spending far too much time on something like that will certainly be a pitfall, more than, let's say, an actual benefit to your team and your overall report.
Looks like there's a couple more questions in the chat. Will dynamic programming come in handy for the M3C? It really just depends. I mean, if there is a clear like 2018's part 3 problem where it was pretty clear that that's what you should do, by all means, it could be handy, but it depends a lot year by year. We've seen all number of examples this year, so I think it just depends. But certainly problem solving skills always come in handy, so it can't hurt. I guess addressing the next question as well, Keshav, if you have anything to add to this too, jump in. I think if you're comfortable with MATLAB, do it in MATLAB. If you aren't comfortable in MATLAB, doing something else that you are comfortable in, I think that's going to be more important than using one specific format, since you're going to be writing a report about it. So it's not like you're sharing a MATLAB file per se, unless you do put the code in the appendix. But yeah, I guess I don't think it really matters what software you use for sensitivity analysis. Just use whatever you're comfortable with.
My personal opinion on this is that the sensitivity analysis is something that you should do. It is very good to write in the report. It is not the bread and butter of your report. If you're going to spend 5 hours on sensitivity analysis, that is not going to help you succeed in this competition. The model itself is going to be where you're going to put most of your effort into. Having a good, well-structured, well-written model is going to be what's really going to stand out. So if so a sensitivity analysis could be as simple as just, we changed a parameter by 10%, we decreased one parameter by 10%, and this is what we got. I would say don't spend far too much time on things that are not the model development and model outputs, unless you have some interesting results in the sensitivity analysis that you do that warrant something more complicated. And again, this is maybe one other point of note is that if you are going to go through some of these processes, these more complicated things like dynamic programming or anything like that, and you think that the code itself is worthy of getting some recognition, then you should explicitly state that you are submitting code for the technical computing prize. And so what our judges will do is take a look at the code itself and judge its ability and its readability, right? So this is something else that you can also consider.
I'm looking in the chat. I guess the question is, what do you do if there are different ways to interpret what's being asked? And what if the team does not agree? How to proceed? And how do you keep your team from falling apart? And how do you keep everybody motivated? That's definitely a big question, because obviously these questions are super open-ended. So there's almost always going to be different ways to interpret it. And it is hard with the short time period to kind of have different people explore different things, because you kind of need everybody to be working on one thing in unison to kind of get the unified report out before the end of the time. But definitely just good communication. I know one thing the teams I was on always like to do was meet right away and talk about the problem and explore all the different ways, like in the first hour, maybe block the first hour out and talk about all the different ways you could approach it, good ways, bad ways, and then at the end come together and talk about which way you want to go with it. But it's definitely hard when somebody does want to do one way, but the rest of the team disagrees. So that's something you should maybe talk about beforehand, like if there is two different model approaches and we don't have time to explore both, because sometimes you do have 30 minutes or whatever to look into one model and then see its weaknesses and strengths, but sometimes that's not possible. So maybe have some communication about majority rules or something, if there is like a clear cut and dry left and right fork, and have that kind of decided before you start the competition can be helpful.
Yeah, I think those examples are all really great. It is important to balance, other people's ideas and being able to explore them. But at the same time, you only have a finite amount of time. And you should, I think, default to something to a rule like what Owen was mentioning. I think that's a really good idea. Let's see. We have a really excellent question in the chat. This is actually, I think, a really fun question. This question is not so much for the problem day, but more for making teams in general. My math team at my school is struggling to find younger members to participate in the M3 challenge in later years. What are some ways that a team could spark an interest in math modeling with others? I think there are a lot of really, really excellent ways of doing this. I think that one method is not thinking of mathematical modeling as, at least in high school, as just being unique to the M3 challenge. There are other mathematical modeling challenges that happen throughout the year that if you kind of continuously think of, put this in the forefront of people's minds throughout, this could be really helpful, instead of, maybe 1 month or 2 months out of the M3 challenge, trying to drum up support from younger students. I think, it certainly is possible to have multiple teams compete from a single school. So I would, maybe recommend having some younger students kind of try out, put them on a team together, or maybe put them on a team together with at least one older person to kind of keep some mentorship aspect going as well. Owen, do you have any other kind of recommendations?
Yeah, I guess I just saw it as being fun, I guess, compared to like other math competitions. I know, at least in my experience, you sit down, you take like a stressful 2-hour test and then you're done. These are a lot more fun. You get to collaborate. And oftentimes I know some people ask, how is math useful? Like, especially some of the math competitions I've done, like more test oriented ones where you're just kind of regurgitating knowledge. These competitions are a little more applied. So you can kind of sell it as, see the math you're learning being applied. I know something that draws some people into math modeling competitions, but also just sell it being fun. You're like sitting down with a couple of people and talking about pretty interesting, cool applied problems. So just trying to show them that they're not just going to be working alone, I guess, on math problems outside of school, I guess. So maybe selling it that way could help potentially.
Yeah, so some other suggestions would be to talk to any instructors that you have at school to kind of bring in mathematical modeling curriculum into their own classes. SIAM has many resources, including this now, as a potential tool for you to be able to hopefully entice other people into getting their feet wet, and hopefully getting them more comfortable. I think, some of the major or not pitfalls, but some of the major kind of barriers to getting people interested in mathematical modeling is kind of the how scary it might be initially, right? Mathematical modeling is certainly not something that you can, well, I would argue is certainly something you could just jump in and start doing. But having a little bit of structure around mathematical modeling, going through kind of the framework that we've tried to instill in all of you during these workshop sessions, can really help. And so taking on small little toy problems that maybe has a clearly defined answer, maybe turning, smaller problems that you might see in class into, something that fits the mathematical modeling framework, is certainly something that might, get people more enjoyed, or get people to kind of jump that barrier, and get people more involved. And also Wesley has included some resources in the chat for other mathematical modeling opportunities. Things like the COMAP challenge is another pretty popular mathematical modeling competition. There are Datathon for Justices for high school students and undergraduates. Datathons in general, I think, are another obviously much more data-centered view of doing mathematical modeling in some ways, and certainly could be something that could be of interest to you as well. Thank you, everybody, for all of your questions. This has been great so far.
I guess another potential note on the question of finding people to do math competitions. I know one of the math clubs I was in high school would go to middle schools and help with their math clubs. So that's potentially something longer term for kind of recruiting the future generation of mathematicians, kind of having that support structure where like high school students go back to the middle school and help with that math club to help drum up interest and keep kids interested. But I guess that doesn't fix the short-term problem, but maybe a long-term outreach kind of thing to do.
Yeah, and I guess I'll speak a little bit. So Owen and I went to the same high school, and our coach was the exact same person. He was also a math instructor that we all just really respected and really enjoyed kind of the way he taught. And so having those kinds of mentor figures is also really helpful. So I would certainly recommend reaching out to instructors, maybe reaching out to people in your local colleges or something like that, and trying to get a little bit more kind of support from outside groups or support from, let's say, older mentors. So I'm going to take a second and take a look at the advice that I had written for myself to see if we'd gotten everything. I think we kind of danced around this thing a little bit, but don't spend too much time on part one. Part one is supposed to be, can you do the problem? Not so much, can you do it in the most spectacular way possible? Part three, I would say, is a part where you can really kind of flex your muscles a little bit, have a little bit of fun, do something a little bit more, let's say, out there. But certainly getting hung up on part one too much will leave you with not enough time to do something really creative and fun for parts 2 and 3. And then kind of a similar, also a similar kind of piece of advice is go into part 2 with part 3 in mind. And what I mean by that is oftentimes part 2 can be a really helpful subset of the part 3 question. So if you go into part 2 thinking, okay, the output or maybe the model that I create in part 2 might be able to help me in part 3, that could be something that is potentially very worth your while, and you kind of get two birds with one stone.
Yeah, I guess just thinking to other advice, to reiterate what Keisha said earlier, leave time to actually submit the document. I know not for the M3, but there was a different math competition that me and my team waited to the last second to record the video we had to do. We had to shoot it in one take, and then I had to upload it, and was just like hoping that the Wi-Fi would upload it fast enough at school. And that's not a fun situation to be in. So leave that extra half an hour to download the PDF, make sure it's formatted correctly, and submit it, because that will save you a lot of stress in the end.
Yeah, and so again, this is maybe a kind of conversations that you have with your team, but the 14 hours is not 14 hours of just math and straight up math, right? Perhaps you should spend the last, let's say, entire 2 hours on just report writing and proofreading and writing that executive summary, because those are the things that are really going to make a judge's life easier. So often when you're writing reports and you're writing papers, you're writing something for your teacher, anything like that, right? Writing to that person is going to make you stand out a lot more. Having something that's really, really well written and simple is oftentimes a lot better than having something really, really complicated and nobody can follow it, right? What was the composition of mathematicians, economists, programmers, etc., on each of your teams? That's a really good question also. So I would say that in my team, it was a team of 5 people. I would say at least 3 people were very competent coders, but I think that we kept 2 kind of lead programmers. Economists, I think we had 1 person who was actually kind of an economy whiz. And the rest, all of us kind of had a decent mathematical background. But I think the group of people who were the coders and the group of people who were the mathematicians oftentimes were the same people. So what we kind of did was, I think everybody worked on part 1 together. We worked on part 2 a little bit kind of more separated, because by then we really needed to start writing the report. And then after a while, we kind of split off, and one whole half of the team worked on part 3. I'd say maybe 3 people worked on part 3, and 2 people kind of stayed behind in part 2, a programmer and maybe like our other more mathematician kind of person were staying behind and working on part 2 to make sure that we had a finished product there. And then they rejoined us for part 3.
I would say pretty much the same thing. I think usually the people in my experience who were doing the heavier modeling stuff were also doing the coding, because usually you have to do some coding to implement the model. So those are usually the same thing. I guess usually everyone on my team had a pretty strong math background, but most people had an interest outside of math usually. So like I enjoyed economics, so I was usually more on the economic side, and we usually had somebody sometimes like on the biology side or more the like physical science side. So definitely just lean into any strengths that anybody on your team has.
Thank you everybody again for all your questions. I think I've kind of exhausted the kind of tips that I had kind of prepared, but of course we're still going to be around answering everybody's questions that you have. What do you do? So a question in the chat, what do you do when you realize that the challenge problem topic is something none of you are good at, if that happens ever? So for me, you know, I knew nothing about economics, and so we were, well, I'll talk maybe a little bit more about the problem that we had in general. Again, my problem was the 2015 problem, which was entitled Stem Cells. It was on the cost of college education and the potential benefits of that down the line. So in a sense, every single one of us, we were all seniors in high school. And so we were all experts at applying to college and stressing over college decisions. However, we were not experts in any way, shape, or form on what happens after college, right? So I would say that that was kind of a wake-up call to us and really helped us kind of, I think, later on, kind of giving us a larger perspective on what happens after college. But certainly, you know, the kind of data set and the kind of supplementary material is certainly something that will be of big help to you initially. I would say that, you know, it is a good idea to either have a dedicated person for this, or for all of you as a team to schedule some amount of your 14 hours to doing research on the subject itself, right? We kind of mentioned this maybe earlier on in our workshop series, that outside of this 14-hour competition, it's always best to consult with an expert in this kind of field, collaborate with people, right? That's how you make models stronger. And for this kind of 14-hour competition, you certainly don't. You have to kind of make yourselves be experts. And another kind of example from my own experience in the competition is that we answered the part 3 of our problem using a game theory approach. And a couple of us we had a little bit of experience with game theory prior, so the mathematical modeling was all right. But the problem is that we needed data that we just simply didn't have and could never possibly figure out, because it was on personal value. How do you personally value the cost of an education, or the cost of, you know, time with your family versus kind of personal ambition, all these kinds of things. If you want, actually, maybe while I'm talking, I can bring up the challenge problem. And I realized I can't do 2 things at once. I can't talk and bring up the problem at the same time. Here we go. So it might be helpful to kind of read part 3 as I'm talking, but you know, one of these, the last part of the problem is A, they're asking for things that have absolutely no units attached to them. B, these are all very much personal things, which none of us really have any idea of, you know, what other people value. We can only talk about what we value, and we're just a very small subset of human beings. And so we just kind of had to add extra assumptions. We think this is how it works. If this is not how it works, then maybe we try this instead. This, you know, kind of talk a little bit more about strengths and weaknesses. That's kind of a little blab, a little mind dump on ideas for what to do when the problem itself is a real world problem that you might not have a whole lot of experience on. But certainly schedule some time to just do some research in the field. You know, simple Wikipedia searches and stuff like that will certainly be a good start on what people are looking at. Maybe find a nice review article on some stuff that people are thinking about currently in the literature, and that can hopefully be a nice citation for you to add in your report. I think I could keep talking, but Owen, if you had any other advice.
Yeah, definitely. I'd also say, don't worry if you know absolutely nothing about the problem. I know there's been times in different competitions. One time there was like the risk of ski resorts, like climate change risk of ski resorts on, or ski resorts due to global warming. And that was something like, I mean, yes, there is a risk, but I don't know anything about like the factors that go into that. So don't worry if you don't know anything about it, like go out, do the research, and you can still come up with a pretty good model. So if you read the topic and you're like, I have no idea about this topic and no one else on your team does, don't worry. Just start going through those resources and doing some research and you'll be fine. You'll be able to get something put together before the end of the competition.
Assumptions and justifications, I think, are definitely your friends here. I think that judges kind of go into these competitions knowing that, you know, we're looking at reports for high school students who only had 14 hours to put together a report. It's not going to be completely devoid of grammatical or mathematical errors. And it's certainly not enough time for you to become experts in any field. So certainly proving to judges that you have thought deeply about problems and that you've kind of thought about the major considerations is certainly something that'll go far. Yeah, this is a good question. When you receive your team results after the competition, and what do you do to start preparing if your team makes it to the final round? So I don't totally remember when exactly we got our results, but the way that it worked when I was a competitor was that we submitted our report. Sometime later, we were invited to New York to give a formal presentation. I believe the presentation is only 15 minutes long for your entire group. And you want this presentation to be fairly well polished. Thank you. The initial results after round 1 are roughly around March 15th. So approximately half a month, maybe a little bit more than half a month. It takes for you to get those initial results back. And so we spent quite a lot of time prepping a really good presentation for that. And then you're questioned by the judges themselves. And so the presentation was kind of set up to be very well polished, you could do it in your sleep, very well rehearsed, things like that. You can actually, gosh, I'm gonna kick myself for this later. You could see mine if you wanted to. I'm sure everybody here in attendance would be very happy to see this. You can see little 18-year-old Keshav. If you scroll down long enough, you'll see it. Yeah, so that's kind of the time frame. And we treated these presentations like a kind of a business presentation, where the goal is to kind of try to convince people that the outputs of your model are kind of the best results possible, the one that the judges should consider most highly of, not necessarily a detailed rundown of the mathematics, right? This should be more of kind of like in some ways, it could be like your executive summary come to life. I'm sorry, Wesley is laughing behind me. It is distracting me a little bit. Oh, thanks. Hopefully that answered that question. Let's see, we have another question in the chat. What do you do to feel less stressed when you start your window? I'm asking because 3 of my team members and I are in an algorithms class that runs until 11:15 p.m. on Saturday, and we're going to do the competition at 8 a.m. on Sunday. So I'm worried about that. Right, that's a good question. Obviously, a very important thing: sleep the whole time in between 11:15 and approximately 8 a.m. on Sunday. A good night's sleep is definitely going to help you a lot. Making sure that your mind is sharp for the presentation itself. So in terms of the time, let's see, when does the challenge window close exactly? Does it close? It closes on Sunday night, I think, right? Sorry, I'm just trying to find that.
So
Yes,
it's Monday, excuse me, Monday at 11 p.m. Eastern.
Okay, thank you, Michelle. So okay, so the what I was going to say is that you're not up against the hard deadline for that for the total competition as a whole. So at least that kind of eases your mind a little bit. But I would say a good amount of prep on what your team's plan is for when you start the competition, I think will hopefully be able to put your mind at ease. There are a lot of variables that you have absolutely no control of until 8 a.m. on Sunday, which is, like, what is the problem going to be? What's the topic it's going to be on? Do we know anything about it? What kinds of math is going to be most useful for this kind of problem? These are things that are completely out of your control until 8 a.m. on Sunday. And so just being ready and open to consider these kinds of challenges, I think, is going to be more helpful than simply going in and kind of be blindsided by what's to come.
Definitely. I know one thing that always helped me was just having all my other homework, at least as much as I could, done that's due like in the short term after that, because you are doing this with school on the next day, I'm assuming, and not having to think, oh, I'm going to finish this competition late at night and then have to start my homework definitely helped kind of keep my mind clear and make me be able to actually focus on the competition. So I know that's one helpful thing that at least has helped me reduce stress during these competitions.
Thank you, Owen, for reminding me of the biggest stressor when I was doing this, which is my other classes and my other homework. Oh man. First off, make sure one of the things you should talk about is make sure we have everybody's dietary restrictions possible. So when we did this iteration last time in the fall, we would always have pizza for our volunteers. And what kind of, we had like we had margarita pizza. Margarita pizza is great. If you can settle the debate as to whether or not pineapple belongs on pizza, my personal opinion is that it does, and I like Hawaiian pizza. We can give other the barbecue chicken pizza, that was also pretty good. The shakaroni is an option, but that's just a very large pepperoni pizza. So while it has a cool name. Oh yeah. So it's a good thing that we're not doing this challenge during Halloween, because one of the pizzas we got was a pumpkin-shaped pizza that was not pre-cut by Papa John's or Domino's, wherever we got Papa John's, and we didn't have any utensils. So that, don't waste time in the competition cutting your pizza. Hopefully that's really good advice for all of you. Owen, did you have anything to add on your favorite types of pizza?
Ooh, I don't know. I think maybe make sure to decide before the competition, so you guys don't have a big argument in the middle about which type of pizza to order. That could be a group conflict to avoid there.
Or perhaps it's leverage. We go
true.
with my model if we go with your pizza. But that is only for maybe groups of people who are already kind of friends with each other. Out of curiosity, did you get extensions on school assignments if you told teachers you were doing M3? I'm pretty sure we did, right, Owen? I'm sure Dr. Teague kind of vouched for us.
Yes, I'm trying to think. I think we didn't last year, but I'm sure if you go to the final round, you can get extensions for things when you're traveling and such.
Oh, definitely, we did that. Yeah, that we definitely needed. We prepared quite a bit for that competition and for that presentation. But yeah, I'm pretty sure I was able to get some out of some of my assignments, and that definitely was a help. Not get out of, but delay the deadline for them. Well, we are pretty much out of time, so I'm just gonna wrap up by saying a whole bunch of thank yous. Of course, if anybody else has any other questions as I'm kind of spewing thank yous, please continue to continue to do so. So first off, thank you to every single person who has joined our workshop sessions, who are watching over YouTube. It's been a great privilege to be able to kind of give our knowledge, our expertise, our opinions on certain things, and kind of guide everybody through the mathematical modeling process. This is something that's certainly a lot of fun. Certainly is something that's really nice for me in particular to kind of not think about my day-to-day work as a PhD student. It certainly is a lot of fun to kind of think back on my time in this competition. It's been a lot of really great help. Thank you to Michelle, who is our liaison for SIAM and the MathWorks Math Modeling Challenge, for giving us this platform to talk to you all. Advertising, the setup, the Zoom space, all of these kinds of things would not have been able to be done without Michelle. Obviously, I have to say a really huge, big thank you to all of our participants, Wesley Hamilton, my co-lead, as well as all of our volunteers, Owen, Julie, Nathan, and Xiao. They did fantastic jobs with running all of our sessions and making them run really smoothly. Hopefully you all learned quite a bit from all of these presentations, and hopefully you can continue to use these as resources for the competition itself, and perhaps mathematical modeling in general, if this is something that you choose to kind of walk down in later on in your life. I think we'll maybe just wait another, I don't know, 30-ish seconds, just to make sure that nobody else has any other problems or any other questions they'd like us to talk about. Will these workshops expand and continue for upcoming years? That is a great question, and that does remind me that all registered participants are going to be, they're going to receive an email survey from Michelle, I believe tomorrow. It would be an enormous help for all of us if you could fill out that survey, tell us things that you liked about this program, things that you didn't like, things that you would like to see differently. This is really going to help us expand and maybe try some new things for years to come. So I would say that it's a possibility, but certainly we would really value your feedback. If you had any feedback for us, you can always contact us at hsmathmodeling@math.utah.edu. And I think with that, we're done. Thank you so much, everybody. This was, I think, really great, really successful. Thank you all for your participation. And happy modeling.
And good luck to everybody participating this weekend.